So again, we'll have an online conference, textbook homework, and we have no IMAX this week. The content of the course this week focuses on the chain rule. Every derivative problem is a chain rule problem. Every derivative problem can use this formula here. And the idea is this is more of an approach than a rule. This originates from the idea of composition of functions from pre-calculus. Before we've seen f compose g or f of g of x. Using the chain rule is looking at a function that's in that format, a function inside of another function. And it just basically tells us to start from the outside and work your way in. We start by taking the derivative of the outside function, and then we take the derivative of the inside function, and we simply multiply them together. That's all the chain rule is about. So let's take a look at an example. So in this example, we are going to find the derivative of the function cosine 4x. Our outer function is our cosine function, and our inner function is the 4x. If we're going to take the cosine of something and then take the derivative, that would be negative sine of something. In our case, the something is 4x. So we also need to take the derivative of 4x, which is just 4. Now we multiply these together. We have the negative sine of something times 4, which gives us negative 4 sine, and what was that something? 4x. And that would be our answer, negative 4 sine 4x. And again, just a reminder that u was just a placeholder. You can use a smiley face. You could even just write the function again if you'd like. But I like to use that u as a reminder to myself that it's just the outside. And then as the last step, I plug my 4x back into the function. So now that we've seen the chain rule and we understand it's just telling us a process more than a rule, that means that any derivative problem that we're solving can be called a chain rule. That's right, any derivative problem is a chain rule problem. The chain rule is again just telling us what order to take the derivative in, and to remind us to take the derivative of both the inside and the outside. So let's look at a problem that will be a proof that any problem is a chain rule problem by tackling one that we know how to solve. Let's take the derivative with respect to x of, let's see, the quantity x squared. That's a good example. Now we know a really easy way to solve it, but let's look at this like it's the chain rule. Our outside function is u squared, or something squared. And what's that something? Just x. So we take the derivative of our outside using the power rule, we'll get 2 something. And then the derivative of g prime of x is 1. Then we multiply them together. We get 1 times 2 times u. U is that g of x, which is x. So our derivative is 2x. Now, we also know the power rule is a great way to solve this and a very easy way to solve this. But this just goes to show that really any problem can be written as a chain rule problem. I don't expect that you're going to write it out like a chain rule problem every time. The power rule is much faster and easier for this. But this is just a good way to look at this idea that any derivative can be seen as a chain rule problem. So again, just showing you that the power rule, we get the same answer. And this is a very common truth in mathematics, that there's more than one way to skin a cat, and there's more than one way to solve a math problem. So hopefully, walking through a few examples and seeing the exact approach of following this process for solving the chain rule has been helpful to you. Now here's my challenge to you. If any derivative is a chain rule problem, then really there is no such thing as a chain rule problem. In fact, we're just doing regular derivatives. We're just taking derivatives the same way we've been. We just now have a new process to help us tackle this function within a function idea. Well, again, I hope you have a wonderful week. Please remember to make sure to make your discussion posts early. Remember to be a part of our conference this week as we start tackling some real life AP multiple choice questions. And please email me if you have any questions. Have a great week.